Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the projections of the oblique planes which happen to be inclined to both horizontal plane as well as the vertical plane. So here we have got a pentagonal lamina which is having edge is equal to 35 millimeter, and this pentagonal lamina, it is resting onto the horizontal plane on one of its sides over there, while its opposite vertex or the corner, it is located at a distance of or a height of 30 millimeter above the horizontal plane. So what information is provided to us through this particular statement? That is, we have not been provided with the angle of inclination of the surface of the pentagonal lamina with respect to HP. So rather than providing the angle of inclination, so the information available with us is that the pentagonal lamina happens to be inclined with respect to the horizontal plane in such a way that it is resting onto the ground or HP on one of its sides, while the opposite vertex will be located at a height of 30 millimeter above the horizontal plane. So accordingly, the angle of inclination of the surface of this pentagonal lamina we are going to evaluate over here. Now since this pentagonal lamina happens to be inclined with respect to horizontal plane, so to begin with, we are going to proceed with the construction of the true shape of this pentagonal lamina onto the horizontal plane in the top view projections. And this true shape of the pentagonal lamina will be constructed below the XY reference line. And further, since the pentagonal lamina, it is resting onto the ground or horizontal plane on one of its sides, so we are going to assume that this lamina, it is resting onto the ground or onto the horizontal plane to begin with. So the front view of this lamina, that is the edge view, will be drawn onto the XY reference line, right? Then next information is available with us, that is the side onto which it is resting in the horizontal plane, it is further inclined with respect to the vertical plane at an angle of 30 degree. So this way we are required to draw the orthographic projections of the oblique pentagonal lamina which happens to be inclined with respect to the horizontal plane to begin with, and it is also inclined with respect to the vertical plane. So let us first of all evaluate the orientation of this particular pentagonal lamina with respect to the XY reference line or the vertical plane. So if we are locating the lamina into this orientation, then we'll find that when we incline this lamina with respect to the horizontal plane, either in this way or in this orientation, it is going to rest on one of its corners onto the ground, either this corner or this corner. So no way it will be resting on one of its sides onto the horizontal plane. So this orientation is inappropriate or incorrect. While if we are going to locate the true shape of the pentagonal lamina below the XY line into this orientation, then if we are going to incline this lamina with respect to horizontal plane in this orientation, so then we will find that the edge of this particular pentagonal lamina will be resting onto the ground, and the vertex opposite to this edge, so it will be located at a height of 30 millimeter above the horizontal plane. So this way both of these conditions, they will be satisfied. So this is the appropriate orientation of this pentagonal lamina with respect to the vertical plane. Now let us proceed with the construction of the orthographic projections of this pentagonal lamina. So as we have discussed, since the first angle of inclination of this particular lamina, it lies with respect to the horizontal plane, so we are going to first of all assume that this pentagonal lamina, it is resting onto the ground, and onto the horizontal plane in the top view we are going to obtain the true shape of this particular lamina. So we are going to construct this pentagonal lamina having edge is equal to 35 millimeter, and we have labeled the corners of this lamina as A, B, C, D and E over here. So this is the true shape of the pentagonal lamina as it is resting onto the ground, and this projection has been observed from the top view onto the horizontal plane. Now, having obtained the true shape of this lamina onto the horizontal plane, now we are going to evaluate the front view projections of this lamina. And since this lamina has got one side resting onto the horizontal plane, so we have to assume that to begin with, whole of the lamina, it is going to rest onto this particular horizontal plane or the XY reference line. So the front view will be an edge view and it will be obtained onto the XY reference line over there. So when we are going to look at this particular lamina from the front side, so the projectors through B and A, they are going to coincide with each other. So the front view corresponding to the points B and A, so they will be located as B dash, A dash in the front view projections over here. Similarly, the projectors through C and E, they will be again converging or coinciding with each other, and onto the XY reference line, these 2 points, that is C and E, corresponding to this pentagonal lamina, so they will be projected as C dash and E dash front view projection points over here. And finally, when we are going to look at this particular corner of this lamina, that is point D, so it will be projected as point D dash onto the XY reference line. So having been able to obtain all the front view projection points corresponding to this lamina, that is A dash, B dash, C dash, D dash and D dash, now we are going to join B dash, A dash with D dash over here, so that we get the edge view projections corresponding to the front view of this particular pentagonal lamina. Now, having obtained the true shape projections of this pentagonal lamina in the top view and the edge view projections of this lamina which is obtained onto the XY reference line into the front view projections over here, now we have to incline this edge view, because we know that this surface of the lamina, it is inclined with respect to horizontal plane in such a way that it is going to rest on one of its edges onto the ground. That is, it will be resting on the edge BA onto the ground, that is B dash and A dash, and this particular opposite vertex, this will be lifted by a distance of 30 millimeter above the ground. So the angle of inclination has not been provided to us, rather the location of this opposite vertex, that is point D dash, so it is lying at a height of 30 millimeter above the horizontal plane. So we are required to redraw this particular edge view projections of this lamina in such a way that B1 dash, A1 dash points, they will be lying onto the ground, whereas D1 dash point will be lying over here at a height of 30 millimeter above the horizontal plane. So these distances we can mark. That is, we have to mark this locus line corresponding to the height of the vertex point D1 dash over here. So this 30 millimeter height corresponding to D1 dash we have marked to begin with. Having marked this distance, now we are going to mark the distance between B dash, A dash and D dash points over here. So this length of the edge view we are going to evaluate to begin with, and then from this point, that is location of the B1 dash and A1 dash, will open the compass is equal to the distance between the points B dash, A dash and D dash in the elevation view over here, and then we'll open the arc is equal to this distance and mark an arc over here so that we can obtain the point D1 dash in the front view projections over here. Thereafter, we'll again open the compass is equal to the distance this much, that is distance between B dash, A dash and C dash, E dash. Now again with this point as the center point now, or the needle point, now we are going to draw an arc which is going to have the same distance as B dash, A dash and C dash, E dash over here. So this way C1 dash and E1 dash points, they will be located over here. Now having located or reoriented this edge view projections which are inclined with respect to the horizontal plane, now we can evaluate the angle of inclination of the surface of this lamina with respect to the horizontal plane. So the front view projections of this lamina as it is inclined with respect to horizontal plane has been obtained. Now the corresponding top view projections of the lamina we have to evaluate. So how we can evaluate top view projections? Now the corresponding top view projections we can evaluate when from all these 5 points over here in the front view we are going to draw vertical projector lines downwards, and once we draw projector lines from all the elevation projection points A1 dash, B1 dash, C1 dash, D1 dash and E1 dash, then from the plan projection view which we had drawn previously, so from all the 5 points of the plan projection view we are going to draw the horizontal projectors and find out the points of intersections between the plan projection points and the elevation projection point. So here we can see this is the intersection point of the vertical projector which has been drawn through the point A1 dash, and wherever it intersects with the horizontal projector line which has been drawn through the plan projection point A over here. So this intersection provides us with the location of the point A1. Similarly, this vertical projector has been drawn through the point B1 dash also. So we have to extend this vertical projector in the downward direction and extend it till it intersects with the horizontal projector line which has been drawn through the point B of the plan projection view. So this intersection provides us with the location of the point B1. Similarly, this is the location of the C1 dash in the elevation. So from this point of C1 dash, now we have to draw a vertical projector in the downward direction and extend it till it intersects with the horizontal projection line which is emerging from the plan projection point C over here. So this intersection of corresponding points provide us with the location of the point C1 over here. Similarly, this is the location of the point D1 dash. From D1 dash, once again we are going to draw the vertical projector in the downward direction and extend it till the point it intersects with the horizontal projector line drawn through the point D over here, right? And finally, this is the location of E1 dash. So from E1 dash we are going to draw a vertical projector line in the downward direction and extend it till the point it intersects with the horizontal projector line which has been drawn through the point E of the plan projection view. So the points A1, B1, C1, D1 and E1. So all these 5 points corresponding to the plan projection, they have been obtained into the top view. Now once we look at this particular top view projection, so we will find that the shape of the pentagonal lamina will be the apparent shape projections in which B1 C1 is the apparent length, C1 D1 is the apparent length, D1 E1 is the apparent length, E1 A1 is the apparent length. But A1 B1, it is the only edge into this lamina which is still the true length, and this is true length because the edge AB, it happens to rest or it is parallel to the horizontal plane. So because this edge AB happens to be parallel to the horizontal plane, so in the top view still we are able to manage to obtain the true length projections of this edge AB, that is A1 B1 over here. Now having obtained the top view projections of this lamina, now another information is available with us, that is the side onto which this lamina is resting onto the ground. So this is further inclined at an angle of inclination of 30 degree with respect to the vertical plane. That is this edge A1, B1. So this edge will be inclined at an angle of 30 degree. Now we have to rotate this top view projection in such a way that alongside this 30 degree orientation line. So here you can check, we have drawn at an angle of 30 degree an orientation line or a projection line to begin with. And now we have to transfer this entire plan projection view corresponding to this pentagonal lamina in such a way that this figure will be reoriented at an angle of 30 degree with respect to the vertical plane in such a way that this true length A1, B1, it will be located alongside this orientation line which is drawn at an angle of 30 degree. So how we can transfer this pentagonal apparent shape of the lamina obtained in the top view at an angle of 30 degrees. So how we can obtain this rotation? Now you can please see, this is a pentagonal projection of the lamina or the top view projection. Now we can inscribe this pentagonal projection or the top view projection into this rectangular box. We can see this is a rectangular box which is inscribing this pentagonal apparent shape top view projections of this lamina. Now once we know this dimension and we know the longer dimension as well as the shorter dimension of this rectangular box over here. Now this box we are going to place over here. So this is the longer dimension of the rectangle which is going to inscribe this pentagonal shape, and this is the shorter dimension. Now having drawn this rectangular construction over here, now using rectilinear distance method, we can transfer all these points onto this position over here. How? So we know that distance between this edge and this edge, it is fixed. Similarly, distance between this edge and this edge, it is also fixed. And similarly, distance between this edge and this edge is also fixed. So we can mark projection line 1, 2 and 3. So with respect to either this edge or this edge over here, so you can see 3 edges we have marked and same distances we have taken from the previous plan projection view. Now another thing we need to know, location of points E1 and C1 will be obtained. So if we are able to obtain either this distance or this distance, so accordingly either you can mark this distance over here or you can mark this distance from this position. So again the location of C and E will be located over here. So now once we have drawn these guidelines, now we know that at the bottom A1 and B1 they should be lying. So at the bottom we have located A2 and B2. At this height from the base C1 and E1 points they were located. So at this height from the base on the corners we have located C2 and E2 points over here. And at the midpoint at the top we knew that this distance from the edge and this distance alongside the height we are able to locate D1 point. So accordingly this distance from the edge and this distance from the base we are able to locate D2. So that is how using rectilinear distances we have been able to transfer or rotate this plan projection view with respect to the vertical plane in such a way that the side AB corresponding to this pentagonal lamina, it happens to exist at an angle of 30 degree with respect to the vertical plane. Now having obtained the plan projection view of this oblique lamina which happens to be inclined with respect to HP at an angle theta and it is inclined with respect to VP at an angle of 30 degree. So the top view orthographic projections they have been obtained. Now we need to evaluate the front view orthographic projections corresponding to this oblique lamina which happens to be inclined to HP and VP both. So now this corresponding view how we can generate? So once again as usual we have to draw vertical projector line from each of these points and extend those projection lines in such a way that they should be meeting with the corresponding horizontal projection lines which are going to emerge from the corresponding elevation projection views over here, which we have already drawn. So let us start. From point A2, we are going to draw a vertical projector in the upward direction. Extend this projector till it intersects with the horizontal projector which has been drawn through the point A1 dash. So this is the horizontal projector through A1 dash, and this is vertical projector through point A2. So intersection of both of these projection lines have provided us with the location of the point A2 dash in the elevation. Similarly, we have drawn a vertical projector through B2 over here, and this is B1 dash. So from B1 dash we have drawn a horizontal projector line. Now the intersection point of these two projection lines have provided us with the location of the point B2 dash in the elevation. Now this is the point C2. So from C2, once again, we have drawn a vertical projector in the upward direction, and we have extended it up to the point where it is going to intersect with the horizontal projector drawn through the point C1 dash. So this provides us with the location of point C2 dash in the elevation. Now this is the location of the point D2 in the plan. So from D2, once again, we have drawn a vertical projector in the upward direction, extended it till the point it is going to intersect with horizontal projector line drawn through the point D1 dash. And finally, through point E2, again we have drawn a vertical projector line and extended this till the point it is going to intersect with the horizontal projector line drawn through the point E1 dash of the elevation projection view. So all the points of the elevation projection view of this oblique pentagonal lamina, they have been obtained. And once we join A2 dash, B2 dash, C2 dash, D2 dash and E2 dash, so we are going to obtain the front view orthographic projections of this oblique lamina. And these are the top view projections of this oblique lamina, which happens to be inclined to both the reference planes, that is at an angle theta with respect to the horizontal plane, and at an inclination of 30 degrees with respect to the vertical plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of the oblique pentagonal lamina, which happens to be inclined with respect to both reference planes, that is horizontal plane as well as the vertical plane. So we will be continuing with further discussion regarding few more illustrative cases of the orthographic projections of the planes in the coming lectures. So thank you very much. Thanks a lot.